Does size matter? Short answer, oh yes, it does. It may not be so apparent to many, but it does, especially when it comes to equipment and the materials and components used inside it. The size of the chassis, how empty and how full it is matters. The size of transformers matters, because larger cores and higher quality cores can take so much more current. They don't get as hot. They have lower internal resistance, so they reproduce dynamics much better. The purpose of this video is to illustrate the superiority and the thought behind why we increase everything in size. So if somebody looks at the size of something and thinks that, why would you want to use a power tube and a source? It's noisy, it's microphonic, it's too big. You know, we have smaller tubes. Why you even bother using tubes? Just go for transistors. They're miniature and beautiful. You can integrate them in the circuits, have an IC, put an op-amp, off you go. It's going to play music, right? Wrong. One cannot expect something to sound large, big, holographic, coming from a small component. It is virtually impossible, because the size of the material and the passive active component which the signal goes through or is being amplified affects directly spatial information or presentation of music. And there's a strong correlation between the size and the size of the holography of the presentation. There's also an interesting thing that a lot of tube lovers are going to agree with me, that when they experiment, say for this, they just swap 2A3 or 300B type of tubes, right? They report such a holography gains when they go for the balloon or the globe-shaped types. And once that Coke shape is being replaced by that balloon globe shape tube, again, everything explodes, like the level of realism improves. There's more vacuum and more space around the electrodes. That's why everything improves in that aspect. The spatial information grows. One can observe that just within the same type of tube when the glass changes. And we are not talking now about different electrode sizes. It's the same electrodes, just in different glass envelope. The size, the musicality, the level of distortion, everything that comes with it is directly affected by the size of that active device. Some engineers that we come across, they ask us, why do you use the through-hole type of components? Why wouldn't we have the SMD, the surface mount components here? What you do here on such a large space and such a large board, we can do in such a tiny thing. We can miniaturize it. Why bother? Why use so much material, so much waste? And the answer is very simple. Because size matters. It's best exemplified by active components. Difference in sound between transistors, power transistors, small signal tubes, and power output tubes. This is very apparent in our products because our performance level system is based on that notion. So we start at the very entry level at performance level 1 with single double triode. So a single tube contains 2 triodes. In order to squeeze 2 triodes inside a glass envelope, the size of these triodes, the plates, the grids, the cathodes, so the anodes, they have to be smaller. Otherwise, they're not going to fit. If anybody heard the difference between, say, a double triode and a single triode in the same tube envelope, for instance, the 6J5 and the 6SN7. The 6SN7 is like 2 6J5 triodes in one envelope. If one places one of those triodes and compares to a single triode, the 6J5, one can hear the difference. Although electrically they're identical tubes, they will display different sonic characters, because one triode that is cramped with another triode in the glass envelope has much less space to breathe than having just one triode in one envelope. Also, the size of that plate changes. Electrically, they're identical, but the sound is different. So a single triode, which has more space to breathe, is going to sound larger and more holographic. That is not possible if one uses a double triode. It's going to automatically sound smaller, more constrained. In our standard DAC, single-ended DAC 2 and DAC 3, we use the mighty 6N6P, which is a double triode. And this is the output stage. we have a single tube with 2 triodes inside. It is a small signal tube which has very low internal resistance and can be used to drive very heavy loads. It's actually a driver tube, not just a small signal tube. It's a great signal output tube between different gain stages. One thing is that, let's take 2 double triodes. The sound is not going to be better because there's still going to be 2 triodes squeezed inside the glass. That is not a solution. The solution is to place less in the same space. If we look at our product range, then we can see that, for example, in the balanced versions of our, say, DAC 2 or DAC 3, instead of the 6N6P double triode, we employ the EL84 pentode. These pentodes are triode connected, so they are triodes and they come in a single glass envelope. If one compares an EL84 or EL82 or EL86 to a double triode inside the same envelope, there's a huge sound difference. The EL84 is going to surpass any double triode there is, because EL84 has larger plates, larger anodes, it has more space, and EL84 are particularly known for their extremely musical and dynamic sound character because they were used in the very early guitar amplifiers. I believe Marshall used the EL84 very much in their early electric guitar amplifiers, and the EL84 were very popular in the radios in the 60s. So it's the 60s, it's a rock and roll type of tube, very energetic. And we use those tubes inside our balanced DACs. So starting with the level 2, DAC 2 balanced, and the DAC 3 balanced, where the tubes are still inside the chassis. They are power tubes. They are no small signal tubes. They are power tubes. As a matter of fact, we have the same tubes inside our AMP1 integrated. They can produce up to 3 watts of power easily, each. Once we move into a performance level 4, we start increasing everything in size. We have even more transformers. We have also larger octal bass tubes. And because they're getting larger and larger, we start employing them outside the chassis on top. The DAC 4 uses the famous 6V6 power output tubes. They're beam tetrode, which were used in the Fender guitar amplifiers. So these tubes are extremely dynamic and they have a lot of body, and these tubes are simply superior in the quality to all the novel, more modern type of tubes. And once we move into our higher performance level, that is the level 5 and level X, we go into very special power output tubes, which are called directly heated triodes normally. And directly heated triodes are the very top creme de la creme type of tubes. The plates and anodes and electrodes inside those tubes are the largest, and they're the most elegantly simple tubes of all the tubes created, because the cathode and the filaments inside those tubes are one and the same. That makes them very difficult to keep quiet because they're very prone to pickups and any noise that's generated in the filaments. That makes them more difficult to design around, but in terms of the sonic qualities, they're superior to any other type. So if we move from the novel or the septal, so the 7-pin one, into novel, the sound expands. If we now move from a novel double triode into a single triode novel, the sound expands. And once we move in this UX4 and jumbo UX4 type of tube sockets, and the tube glass becomes larger and larger, so we move into the power output tubes. The plates, the electrodes become larger and larger, and the distortion goes lower and lower. The holography and the sound, what some people call soundstage, that presentation, this spatial presentation, grows in size. If one can observe this trend across the tube sizes, what can one say? Size definitely matters.